How does that look? Participants can see my screen. That doesn't. Okay. So what I'm telling a bit about compiler toolchains. So if you how to say it, the talk has two points of view. So on the one hand, if you have your own source, C, Fortran, C++, and want to compile that, a compiler toolchain is what you need. And you need to understand compiler toolchains in order to get a good executable. On the other hand, if you use software which has been compiled with a compiler toolchain, on most systems, with the exception of Tetralead, you need to load the same toolchain when running the software. That is because libraries, for instance, a compiler sort of does two things. When you compile the software, it compiles the software. When running the software, it provides a lot of functionality. It starts out with, for instance, a square root. Out of the box, C doesn't know what a square root is. You need to provide it a runtime to explain what there needs to be a library which explains what a square root is, and you need to have the correct version. So that is why toolchains are important. If you use software which has been compiled by the support teams, then typically, as discussed during the morning, the software, to use the software, you have to load a module, and that module typically takes care that the correct toolchain is loaded. So let's start now. So the objective is what toolchains are and why they are used, be able to find which compiler toolchains are installed, and be able to load the compiler toolchains you want. So many HPC centers in Sweden and actually in Europe, they provide a concept like toolchain. It's not always called toolchains, but that is typically a set of it's typically a compiler and a set of libraries which are widely used for high-performance computing software. So the libraries are message passing libraries, if it's a parallel computing program, linear algebra libraries, and other fundamental programs. And in order to do that, you need to load the toolchains. So toolchains, what they do is they keep matters consistent. Everything is built using the same compiler and the same underlying libraries. So how it works is that you load a toolchain. It comes with a bunch of libraries already, which most high-performance computing systems need. So message passing library, linear algebra. There might be a fast Fourier transform library. And then if it needs more libraries, you load a module for each library, which is built with the same toolchain. In the end, the whole thing is out of one sort of one piece. Everything is compiled with the very same software. So it provides another thing the toolchains do is they provide access to a modern version of the compiler. If you have a service which has been running for many years, so for instance the Tetralead service, the compiler in the operating system is very old, and that typically doesn't offer recent levels of language standards. So if you compile a modern piece of software, it might not compile it because there are things used which are not in there. It has the latest optimization techniques. So in short, this system compiler is not good, and don't use it for compiling software. The only purpose it actually serves is that we can compile a modern compiler. So quite often I see users connecting to the service and just typing GCC and to compile software. This is what you not should be using. You should load the toolchain, and then if you then type GCC, you get a modern version. And I mentioned that already. The toolchains integrate with the module system. So if you load a toolchain, it will offer you libraries. So for instance, I/O libraries, performance libraries, which are matched to Link. So the other day I had a ticket here in Lund, and a user complained the software wouldn't work, and she took bits and pieces which were compiled with different compilers. So this is going against the grain. If you build software, don't use -else. Don't search around where is the library. I need an HDF5. Some users go in and search the system, where's an HDF5, and that's a recipe for disaster. You should check which module provides HDF5 and load that. And the system is typically set up in a fashion that you can only load HDF5s which match on your current toolchain. Okay, let's go a bit further. Toolchains for regular CPU nodes. So let's perhaps start here with the Dardel system that uses the Cray programming environment. So it's not called a toolchain; it's there called a programming environment. So to start off with, you can load the Cray programming environment. ML module which is a short for module load. CPE stands for Cray programming environment, and 24.11 is the latest on the system as of yesterday. Then to use installed software, you might need to load a PDC module. So for instance, just ML PDC, and that should give you the latest, and you get the latest version of all the software built against the latest programming environment. Sometimes users have need to access an older software version, for instance, because they started a project 3 years ago when that was the current version, and they want to continue using the old version to keep everything consistent. You might then have to look into the PDC old modules to get the older version back. In contrast to other systems, Birgitte mentioned that already, it is not advisable to do a module purge on Dardel when wanting to remove software. So what you can use is module unload, that takes the module away. You can do a module swap, that exchanges one piece of software for a different one. So for instance, if you have loaded version 3 of a software and you want to go back to version 2, you do module swap, software name version 2, modules software version module 3, and then it exchanges. Or you can just load a different software, and the system is set up that it spots conflicts and unloads everything which is in the way and reloads something which doesn't have a conflict. Please pay close attention to the error messages. Sometimes the system cannot sort you. Try to sort yourself, or if you struggle, please write a support ticket to NAISS, and then we will have a look and advise you. The last thing we want is that you get rubbish results. So if you struggle with all this stuff, write a support ticket, somebody will advise you. They might need to install software to get it matching or whatever, but don't suffer in silence. So actually, it's 4 compilers. So on that day, 4 compilers are available. By default, you get the Cray compiling environment CCE, which is commonly referred to as the Cray compiler. In addition, the GNU compiler suite, the Intel programming environment, and the AMD AOC compiler are available. The compilers can be accessed by loading one of program environment Cray, program environment GNU, program environment Intel, or program environment AOCC. So how I would go along if you're connected, this is loaded by default. And if you prefer or would like to test whether if you compile your software and would like to test whether, for instance, program environment GNU gives you a better performing executable, just ML program environment GNU, and it kicks out everything which is related to program environment Cray and reloads the modules which are compatible with the GNU. The modules here, they provide a Cray libc, which provides, for instance, BLAS, LAPACK, and SCALAPACK, and a gray mpitch, which is the MPI library you should be using on Dardel. If you're using easy build, you might need to look into these compiler chains, and here we have links to the relevant documentation on the Dardel website, which explains things further. If that, and as I said, if you struggle, please submit a ticket. So on Tetralit, we have here tool chains are called build environments, and for CPU code, build environments based on the Intel compiler and the GNU compiler suite are provided. So to check the versions, you can do module avail build env -gcc or module avail build env -intel. And then you can check the versions which are available. And if you, for instance, use the command module help build environment -gcc, and here I have specified an explicit version, it tells you what it does, what is included. So when running that, in case of build environment gcc 23.b, it includes OpenMPI for MPI support, OpenBLAS for BLAS and LAPACK support, FFTW and ScalarPack, in addition to the GNU compiler suite. On the other hand, if you prefer an Intel compiler, build environment -Intel 23A-EB that contains the Intel C, C++, and Fortran compilers, Intel MPI, and Intel MKL. Quite often at that point, I get the question, what should I use, GCC or Intel? And the short answer to that is that what gives you the faster executable. So if you intend to spend a lot of time with that application, it's worthwhile to build it once with GCC and once with Intel, and then watch the horses run. What is faster wins. There's no general Intel is always faster or GCC is always faster. Sometimes it might also be that you struggle to build your software with GCC, but with Intel it is easy, or vice versa, then just go for that. Then here I just pick out Kebnekaise. These systems are often set up very similar. They provide tool chains taken out of easy build. And it provides GCC compilers and Intel. So what I said about Tetralit applies here as well. What is faster wins. And general, I would typically pick this one if I want Intel. If it had, this is the most complete one. You see these are subset. Perhaps this is an alternative if you prefer MKL over OpenBLAS. But other than that, if you don't want MKL, if you like to stay with the open source software, I would say take this one. Here are a few more things. If you don't need them, they are not in your way. Similar, if you prefer Intel compilers, I would take this one. So the MKL is out of Intel. It works very good on if you run on nodes which have Intel processors. If you have AMD processors, it can sometimes be a bit tricky to get performance out of that. So MKL provides BLAS capabilities and FFTW, BLUX, and ScalarPack. So these and these are essentially equivalent. They provide the same set of libraries, and everything in here, as I mentioned before, the FFTW, the BLAS, the ScalarPack, is compiled with this very version of GCC in here. So here we have tabs for Cosmos, Pele, and Bianca. And Bianca is a bit different, but Pele and Cosmos are set up very similar to Kebnekaise. CUDA, up to very recently, we didn't have any NVIDIA GPUs on Tetralit. So here we have a few tabs of what you should do on which service if you want to supply, if you want to compile CUDA nodes. Please keep in mind that these machines have very limited GPU capabilities. So selecting a tool chain, we have here again tabs. I mentioned that before. You have a choice of 4 compilers on Dardel. And yeah, on Tetralid, you have 2. And Cosmos, Kebnekaise, and Pelle, you have, I would recommend to use either of these 3, unless you have special needs. So then you can query, for instance, module avail FOSS. It shows you all the versions, and then you have to pick one. If you have specific question, you can use module help. I had shown that module help FOSS 2024a. It tells you something about the module, and if that doesn't help, module show FOSS 2024a does what the module would do. It tells you all the libraries, but it typically tells that in Lua. So you need to digest the code. As always, if you struggle, send us a ticket. Here you have an example. If you load FOSS 2024i, that's an example from Cosmos, that module sits here, and you see how many other modules it gets in. Some of these modules can be very unintelligible, what they do, or need expert knowledge. On the other hand, here you see it's GCC 13.3. So that is an alternative way of checking. Just load the module and see what you get. So here you see it's GCC 13. You find things like OpenMPI 503. You find the version of OpenBLAS. You find the FFTW version in there. You find the scalar pack. So here you get the exact versions of what you see. And everything what is in here has been compiled with this GCC 13.3. FFTW MPI needs MPI. It has been compiled with this against this OpenMPI such that everything is consistent. So if you compile software, depending on which service you are using, you have to call the compiler with a different suite. On Dardel, it's very simple. You take the programming environment for the compiler you like, and then there's a Cray or HPE provided compiler wrapper that is a script which is set up against the programming environment. And if you, for instance, have standard C code, irrespective of whether it's serial code or MPI code, just use CC to invoke the compiler, and then it knows where the MPI library is, where the BLAS library is. It knows which compiler you wanted because you choose that with the programming environment, and it just works. What you have to take care of is that the optimization flags you still have to, they are still compiler dependent, and you have to look that up for the compiler which you have selected with your programming environment. So it's CC for C code, capital CC for C++, and FTN for Fortran. If we go on to Tetralid, it is if you have a built environment GCC, use GCC, G++, or G Fortran to compile serial code. And use if you have MPI-CC, MPI-CXX, or MPI-iFort to compile MPI code. Again, here, this is a script. This is a compiler wrapper. It knows, since you have selected build environment GCC, that you want the GCC compiler. And then it also knows where the MPI library sits. So you don't need to do anything like linking the MPI library. You just compile like ordinary code, and it tells the compile where to look for the specifics of the MPI library. If you use Intel on Tetralid, use this you have to use for serial code, and this is what you have to use for compiling MPI code. If you use a system which has been deployed on the basis of Easy Build, which includes Kebnekaise, Cosmos, and Pelle, this is if you have a GCC-based toolchain such as FOSS, you use these to invoke the compiler. If you have an Intel-based toolchain, you invoke that. For the compiler. Here we have listed two commands, depending on whether you have a new version of the Intel compiler or an old one. If it's new version based on Intel's newer one API, you have to use ICX for C compiling, ICPX for C++, and IFX for Fortran. That is for if you have an older version of the Intel compiler, use the older ones. Then here if you have the Intel toolchain that uses the Intel MPI library, please use these calls to invoke the MPI compiler to tell which MPI library you use and which that it should be using the Intel compiler. Okay, that is me on toolchains.